My name is Birkan Denizer. Without my work, autonomous sailing would be less reliable. I'm a research assistant as well as a PhD student working in the field of computer science in the Kiel University. I work in the CAPTN Fjord Area Project, which aims to create an autonomous research vessel that can sail by itself in the Kiel Fjord. My research task is to improve the communication between our research vessel MS Wavelab and the control center on the land. The main problem is that when the ferry sails, the network quality changes, which means we need to make some prediction. To provide a reliable connection, we predict the upcoming network quality and do switching between the links. If we don't adapt the network we have, that results in intermittent disconnectivity and loss of remote control. My research is also relevant for other autonomous vehicles such as cars and trains. Without network adaptivity, we would end up losing the connection for very brief seconds, resulting in unstable sailing behavior. Imagine it as like one continuous network, but if we don't have the network adaptivity, then we would have many breaks during the connection, which would result in unstable behavior. For remote operations, we rely on multiple 5G operators as well as a satellite connection. We continuously measure the network coverage. For example, here you can see that we have two different operators that have different quality networks. We show green as the good coverage and red as the bad coverage in the city. After our measurements, we use the measurements to make bandwidth as well as handover predictions. For example, you can see on the left, we predict upcoming network handovers with more than 90% accuracy, and then we use that in our machine learning model to make bandwidth predictions for the uplink in the next few seconds. Here I'm using three models. My first model is about predicting the downlink bandwidth of the 5G connection. The second model is about predicting the upcoming network handovers. And the third model is about predicting the uplink bandwidth of the connection. And this model also uses my handover prediction from the second model as an input. All three of our models are efficient, meaning that they use less energy and resources for making bandwidth predictions. For me, a combination of hardware as well as software keeps my research interesting. For example, I get to test multiple 5G routers from different vendors. I collect a lot of measurements, and with the measurements that I collect, I develop machine learning models. And then in the end, I can also test the machine learning models on these Jetson devices. They are small edge AI computers, which allows us to measure the efficiency of our models. And then eventually they get deployed on the real ferry on the MS Wavelab.